In this lesson, we'll talk about neutralization reactions between acids and bases. We are specifically going to look at the reaction between strong acids and strong bases. And what that means is that the acid or the base completely dissociates or breaks apart when it's in water. So the common examples for acids are sulfuric acid, perchloric acid, hydrochloric acid, nitric acid, hydrobromic acid, and hydroiodic acid. For bases, it's any soluble hydroxide from groups 1A or 2A on the periodic table. That's the left side of the periodic table. For example, strontium hydroxide, sodium hydroxide, potassium hydroxide, lithium hydroxide. These solutions will have very high concentrations of hydrogen ions for acids. Remember, acids start with hydrogen. So here would be your source of those hydrogen ions. And then for bases, you have very high concentrations of hydroxide ions. And because you have these high concentrations of ions in solution, the solution conducts electricity really well. So we say strong acids and bases are strong electrolytes. They're very good at conducting electricity. On the left here, you can see an example of a strong acid represented here with the red dot and the white dot together. And then when it's in water and when it's in solution, you can see that the red dots and the white dots have separated. So complete dissociation, they have completely broken apart into ions that are now floating around in the water. When an acid or base does not do this, we refer to it as being weak. And you can see over on the right, many of those molecules are still intact. The red dots and the white dots are still stuck together as a molecule. So now let's talk about the reaction between a strong acid and a strong base. This is going to be a neutralization reaction. They're going to neutralize one another, and this is going to be a double replacement reaction. Products are always going to be water and what we call a salt. Salt is just an ionic compound. Here we have sodium hydroxide and hydrochloric acid. So we have our base, our strong base, sodium hydroxide. It's a soluble hydroxide. Got the little aqueous there. And then we've got hydrochloric acid, which is a strong acid. We're going to do double replacement. So swap out the cations or swap out the anions. You get Na paired up now with the Cl. Sodium's a +1 and chlorine is a -1. So NaCl is the correct formula. And then you get hydrogen paired up with the hydroxide. We're not going to write HOH, we're going to write H2O. Water is a liquid. And then if you look at your solubility rules, you get sodium chloride as soluble. That's aqueous. So that's our salt. And it should be a soluble salt. And then, of course, H2O is water. Then you just need to balance the chemical equation. And this one requires no additional balancing. So now let's do one more. We're going to write the balanced chemical equation for the reaction between potassium hydroxide and nitric acid. Potassium hydroxide is a strong base, soluble hydroxide from groups 1A or 2A, and nitric acid is on the strong acid list. And so we're going to do neutralization, double replacement. Swap out the cations or swap out the anions. You're going to get KNO3, so the potassium and the nitrate together, +1 and -1 for the charges there. And then HOH, instead of writing that, we're going to write water. A little L on the water, and then all nitrates are soluble, and we should always get a soluble salt for our product anyway in a neutralization reaction between a strong acid and a strong base. Don't forget to balance the chemical equation. However, this one requires no additional coefficients. So hopefully now you know how to write a neutralization reaction between a strong acid and a strong base.